Hello global friends, I'm Konstantinos Thanassias, Professor of Electrical Engineering, go by Kondithan, and today we're going to present a new innovative training educational model. As you know, the technical training usually includes two things, the theoretical knowledge and the hands-on learning. Unfortunately, these two teaching methods are already old for the new Industry 4.0 and the state-of-the-art technology. We're gonna need something more about this. We're gonna need a hybrid educational model. And yes, this is the topic of today's presentation. To design a hybrid educational model for automation systems, and specifically we're going to speak about the integration of the digital twin technology and simulations to address the needs of Industry 4.0. A practical approach to the training and upskilling of industrial workforce. As you already know, the rapid evolution of Industry 4.0 leads to the increased skill requirements that the workforce personnel couldn't have. So industry couldn't find the necessary people to work directly on the desired posts. So it is created a gap between the theoretical education and the real world industrial practice. Unfortunately, the traditional teaching methods, they have a lot of limitations. As a result of all of this, we have this here, the skills gap. We're going to approach this hybrid educational model through the ADDIE model. ADDIE model is a very famous educational model that it consists of 5 phases: analyze, design, develop, implement, and evaluate. This is a continuous cycle, never stops, never ends, and with this ADDIE model, with these 5 phases, you can create a course from scratch, from the very beginning to analyze up to the end to evaluate. So we use this ADDIE model, and with that way we create our hybrid educational model. So this is the architectural framework of the proposed hybrid educational model. It consists of 4 main cores: theoretical knowledge, simulation, physical system, and the physical system you can see here, right? This is the physical system. You're going to see later how it works with our computer, what has happened specifically, and digital twin. To understand better this architectural framework of the specific hybrid educational model, we're going to use a training scenario, a case study. This scenario will be a temperature monitoring and protection system for a critical equipment room. This is the device here, okay? This is the physical system, and this system, it has 2 inputs, a sensor and a switch. So depends of the temperature of the room. If it is less than 24 degrees, we have a normal status, so we have a green LED as an actuator that we can see our results. If it is between 24 or 32 degrees, we have a high temperature and yellow status. If it is above 32, we must have an alarm status, so red. If the temperature sensor for some reasons doesn't read values, so we have a fault status, and we're gonna have a white LED in our system. Also, we have a reset switch with which the user can reset the system, for example after an alarm status, so we can work again in the normal status. Let's see together and start with the physical implementation. So let's pass now to the physical implementation, and let's start to describe our physical system. We have 2 main CPUs, one microprocessor Arduino Uno and one mini PLC from Schneider Electric, the Zelio series. The Arduino Uno does the edge layer, so it has all the sensors, in our occasion one reset switch and one temperature sensor DHT11, that through these 3 relays drives the mini PLC, and in continue this PLC drives our actuators. In this occasion we have some LEDs that they simulate the real occasion. For example, red LED is the normal status, the yellow LED is whenever is activated the fan motor, the red LED is whenever is activated the alarm, and the blue LED is whenever the user activates the reset switch. Also we have a white LED here whenever the temperature sensor does not read the values. Now we will pass the simulation that we use the platform, the online platform Tinkercad for the Arduino Uno, and of course we use the Zelio Soft 2 for the mini PLC Zelio. So we will continue with the simulation phase. Before we check anything to our physical system, we must be sure that our system is working as is expected to be work. Here you can see in the main screen that we have 2 main programs. One is for the Zelio of the program, the software called the Zelio Soft 2, and the other is the Tinkercad online platform. It's for Arduino Uno. So with these two platforms we can simulate our edge layer device, that is Arduino Uno, and the control layer, that is the mini PLC. So let's start, for example, with Arduino Uno. Okay, we start the simulation, and if we're gonna make some zoom, you're gonna see the yellow LED. It means that the temperature is more than 24, and yes, it is 25, so that is the reason that the yellow LED is open. Let's go to 15 degrees, so you can see now the green LED is open, so we have normal status. If we raise the temperature above 24, it will have the yellow LED, and if we raise it more, so let's say 40 degrees, we have the alarm system, we have the red LED, and also we have this buzzer that it says that something is going wrong. So in case that the temperature goes up to down to 24 degrees, our alarm will not get off, because we said that it must be acknowledged from the user, and this it happened with the reset switch. So we open the reset switch, and again we have the green LED. Another situation that it can be happen is, of course, what I didn't say is that when we put now the reset switch on, you see also the blue light is on. So we close the reset switch and the blue light is off. Another thing that it can be happen, if we stop the simulation and put out the temperature sensor, for example, we can delete this line. What it will happen now, because we don't have a sensor and doesn't read the values, we have the white LED, so the fault status, again the buzzer, again the alarm, and of course again the fan, because we want to activate the fan system, so as in case that something has happened to cover the worst case scenario. About the monitoring, this is the two screenshots. Here is the from Arduino IDE, we monitoring through the serial monitor, and here is the monitoring through the software program of Zelio Soft 2, and specifically we are in the status of monitoring. Before we were in the status of simulation. So let's pass to the monitoring phase. So our system is working, and you can see here through Zelio Soft 2 program that is in monitoring mode. It means that is totally communicated with our Zelio. And also Arduino, here is the Arduino IDE program, and here is the serial monitor that it takes the data from Arduino Uno, and you can read that we have a normal temperature of 20 degrees. So that is the reason that we have green LED, so we have a normal status. And we're gonna see now if we approach a heating element to our sensor, what it will be happen. So we approach a heating element close to our sensor to see what will be happen. We see 22 degrees to the serial monitor, 23 degrees, 24 degrees. Now it activates one relay. We have a delay on time for mini PLC Zelio, and after 15 seconds we're gonna see the fan motor, the yellow LED. Now we have 31 degrees, 32. You see the second relay is giving alarm, but still mini PLC doesn't give the red LED because we have delay on time. And about now, so now we have the alarm status and the red LED. Okay, you see here the serial monitor 34 degrees, and also you can see at the Zelio Soft the red lines that is already activated the fan motor and also the alarm status. The temperature is 34 degrees. Okay, so we're getting away the heating element, and let's observe how our system now reacts. So the temperature is starting to decreases. Okay, 32 degrees, still the program, it says in the Zeliosoft we have the fan motor yellow LED and the alarm red LED open. We can see also in our board, and look, now we have 31 degrees and 32. You remember what we said? So as to protect our control layer, the mini PLC doesn't directly take this sensor. So now, after 15 seconds about, we have the final output. But be careful, because we had an alarm, what we said, that if the user doesn't acknowledge the alarm with a reset switch, it will be remain open, so for security reasons. So the user, what we will be must do now to activate the reset switch. You can see here the blue LED, and also you can see in the serial monitor that it says the reset button has been activated. Also you can see in the Zeliosoft program that we have activate the reset switch. This is, my global friends, the monitoring. This is how you can see everything through your computer, through the physical system, and what is happening. So we close the reset switch and we have again activate fan. But remember, not yellow LED because of the delay on. You see, now it is open, the yellow LED and the motor fan. So we have 27 degrees. Okay, so it's normal that we can see the yellow LED. Also in the Zeliosoft we can see that the fan motor is on. Nice. This works also vice versa, because I can go here through the computer, my program, release all. Are you sure? Yes. You see, what I did is from the program to release the switch, because this is the monitoring through the computer and through the PLC. I can activate, for example, force and maintain the first switch. You see, delay on, and after 15 seconds it's gonna open the yellow LED. But I force it through my computer. Okay, release all. Nice. The temperature now is 21 degrees, normal temperature, and for that reason we can see the green LED. What it will be happen if the temperature sensor does not read the values? White LED, as we said, in monitoring Arduino IDE we have an error, we cannot read from DHD, we have a message, buzzer on, and fan motor and alarm system, so as to alarm the user to go at the area to see what is happening. And also here you can see in the Zeliosoft what is happening. If the temperature sensor gets back, nice, we have normal temperature 20 degrees, but the alarm red LED does not go off, because we told it should be acknowledged by the user. So with the reset button, blue LED, okay, reset button has been activated, and we take off the red alarm. So this is the monitoring phase. And let's go to see how is the data visualization, so as to have as a control panel level of industrial and HMI and SCADA, so how it can be seen, this system in our monitor. And now is the data and results visualization is through the program of processing, and this is the control panel that the user see in the industry. This is the main control panel that it would be in industrial area. Okay, so here we're gonna use the processing program to visualize our datas. Here is the control panel. We have 18 degrees as you see. The system current state is normal. We don't have any faults. It says that the green LED, it should be on. Okay, we see it also here, green LED, everything is okay. And here also we have the trend of the last 5 minutes, how the temperature is going up and down. Also all of this data we're gonna save it in a CSV file, so as to have the history. So let's see what it will be happen whenever we approach a heating element to our device. So we put something warm close to our sensor, and you can see that the temperature goes 19, 20 degrees, 21, 22, 23, 28. You're gonna see the first relay, and after 15 seconds, because of the delay on, we're gonna have also the PLC. Now we have the system current state fan. Yellow LED, the temperature continues to raising up, 31 degrees, goes up. Now it started to give the alarm, but because it is not stable, it cannot. But now it is stable, so if it passes 15 seconds, our system, the PLC will, okay now. So the PLC gives the output of the red LED, so we have alarm status, so we can see it in our system. Okay, red LED, the alarm, yellow LED, the fan motor of course tries to lower up the temperature. Okay, in our panel we see the 32 degrees, the current state is alarm, and here you're gonna see the diagram how it goes up. Okay, and now goes down again to 31 degrees. So the system current state is fan. Okay, because we had an alarm, you can see here, press alpha to acknowledge alarm. So I go to my keyboard, I press alpha, and for that reason I know that the alarm has been activated. 29 degrees, it goes to diminish. Okay, what else we can see on our control panel? Yellow LED is on. Okay, but like you noticed is that the red LED, the alarm status in our physical device didn't go off. Why? Because like we said, it must be the user with the reset switch who will acknowledge that we had an alarm. So with the reset switch on, what is happening? See at the control panel, relay reset on. We can see it also in our physical system, blue light here, and now close. And we close the alarm system with this way. Okay? System current state normal, 22 degrees. The system goes now in normal situation. So here is the time and the event, what is happening, and in the upper right corner you can see how many fan counts we had, how many the fan motor activated, what was the time of the fan, so how many times the motor worked, how many seconds or minutes, depends, we had an alarm. All this data are very important for industrial area, because you can check what is happened when the user was away from the specific room that we are monitoring the temperature. And let's gonna see what it will be happening in the case of the temperature sensor doesn't read the values. We're gonna see this also in our control panel. So temperature is off, we have an alarm, and we have a fault, sensor fault. Okay, red LED on, in fact all of the relays are on, so the fan and the red LED, the alarm, and also the white LED, as you can see, and also the buzzer. Here you're gonna see also the alarm count, and of course all of that, when they are used together, the physical system, the simulation, the monitoring, and the visualization, they create the digital twin. Of course, this is not enough so as to deliver a successful lesson. Of course, you will need some educational material. You will need for sure a lesson plan, a presentation, a student worksheet, a practical exercise guide, a syndicate exercise, and a lesson feedback form. Here we end this presentation. We spoke about the design of a hybrid educational model for automation systems, specifically about the integration of digital twin technology and simulations to address the needs of Industry 4.0. This is a practical approach to the training and upskilling of industrial workforce. My opinion is that all the professors must try to evolve about their teaching methods so as to be better and to deliver more customized education. And of course, please remember, train as you work. See you. Take care.